This is a video series on C for embedded systems. In the previous video, we have seen how do we create a C program. So if you have not subscribed to the channel, please subscribe. So you can help others find this video by liking this video so that YouTube algorithm recommends it for others so that it will be helpful for them. Well, in this video, we will dissect a simple C program. So what it dissect means, we will go through a simple program and understand what each line is and what are the elements of this program. So that means what constitutes a C program, and let's understand it a bit more detail. Okay, so the first thing is we have written this. So you can copy and paste this and execute it so that you know what's really happening. So first of all, I'll just try to compile it. You can watch my previous video on how to create C file, compile and execute. GCC. The name of this file is dissect. So I'll go to this source directory and then I'll do GCC then dissect.c file. So basically what it does is it creates a file called a.exe. Then I do a.exe. I execute it. It prints this program is meant to dissect. So this is a simple program which just prints the prints this message to your console. Console is your terminal. So that's the basic of program here. So let's understand each line what it is doing. So you can see there is something which is between the forward slash and the star and the forward slash. So anything that is between this is called a comment. So comment is not actually part of the program code. That means the comment is not going to be executed in your program, but that is telling the compiler that not to do anything for this lines of text. So it is simply a comment. So it is here to remind you or someone else reading your code so what the program does. So that means anything between the forward slash star and star forward slash is treated as a comment. So as soon as your compiler finds this, so it will simply ignore anything that follows, even if the text looks like program code, until it finds a matching uh, star forward slash. So this is about the comment. And there is also another type of comment here. It's called a single line comments. So everything that follows two forward slashes on a line is ignored by the compiler. This form of comment is less cluttered than the previous notation, especially when the comment is on a single line. So for example, you can see in the code, I have included #include stdio.h, and on the same line, you can, on the same line, I have commented it. So that is kind of course, it is possible with this, but normally we use this for multi-line comments. So you should try to get into the habit of documenting your program using comments as you go along. So your program will of course work without comments, but when you write longer programs, you may not remember what they do or what you have done in the previous week, for example. So put enough comments to ensure that you are well documenting the code so that it helps you in the future, also others who read your code. So always remember that you write code for other programmers to read than to execute on a machine. So that means you write a better code for the other programmers to read and understand. So most of your career, okay, let's say if you're an embedded engineer, any programming for that matter, so most of the time is actually goes in reading somebody else's code. So you're actually doing a favor to other engineer or a colleague by writing a good code. So by writing a well documented code. So always make sure your code is documented and readable. So there are other things, not just commenting. So using meaningful names for your variable and things like that. So it's writing code is also an art. It's as if writing an essay or writing a story. So that is how it is. So always make sure to write well. And commenting is one such good practice. Well, coming back to the program, there is something called pre-processing directives. So in this program, you have hash include. So the symbol hash indicates this is a pre-processing directive, which is an instruction to a compiler to do something before compiling the source code. The compiler handles these directives during the initial pre-processing phase before the compilation process starts. So you can see in my previous video more on the pre-processing. But here the pre-processing is basically anything that is there hash next include or hash define. Such things will be expanded into a single file. So in this case, the compiler is instructed to include in your program the contents of the file with the name stdio.h. So stdio.h is a header file that is because it's usually included at the head of the program source file. So that's why normally .h files are called header files. So in this case, header file defines information about some of the functions that are provided by the standard C library. But in general, header files specify information that the compiler uses to integrate any predefined functions or other global objects within a program. So what it means is that you have any .h file. This .h file is an interface. You can think like as interface or an index to a library. So with the .h file, the compiler knows that what are the things that this .h file offers, and that will be part of a library or a .o file or a .object file. So this is very important. So without .h file, you cannot have you cannot expose your library functions to the other library or other program. It's other code. So you'll be creating your own header files for use with your programs. So that we'll do it in future. But in this case, because you're using a printf function from the standard library, you have to include stdio.h header file. This is because stdio .h contains the information that the compiler needs to understand what printf means, as well as other functions that deal with the input and output, such as its name stdio is shorter for standard input output. So all the operations that are done by the standard input output are exposed by this stdio.h. So if we want, we can actually see this stdio.h. You can see it defines it's a big file. So it defines a lot of things. So standard input output functions will be available here. Okay, so if you see this code, so what we have covered is you have hash include, and you have covered these are the comments. And let's come to the main function. So defining the main. A function is just a named block of code between braces that carries out some specific set of operations. So every C program consists of one or more functions, and every C program must contain a function called main. The reason is being that the program always starts execution from the beginning of the main function. So here you can see that this is the return type. Int is a return type. Main is a name of the function, and anything that is between these brace brackets is the parameters that will be passed to a function. Okay, and in this case, the return type is int, and the name of the function is main, and it does not take any arguments. So that's the understanding. We'll see that in a little bit more detail. So this defines the start of the main. So notice that there is no semicolon at the end of line. So here if you see int main void, so there is no space. Int main and void. There is no semicolon here. The moment you put a semicolon, it becomes a declaration. So this you would normally see uh, in a header files. But if you remove the semicolon and start this with the brackets, and anything in between is body of the function, and this is the function definition. So with the semicolon you have a declaration. So you will also find this return statement. This is a return statement that extends execution of main and returns value 0 to the operating system. So what it means is that it returns the value 0 to operating system. That means the main function is called by the main function is actually called by the OS thread. So this is very important concept. So OS thread will actually call your main function, and you have to return something back to the OS to indicate that your main function executed successfully. That is why we return 0 here. In this example, there is the word void between the parentheses. This signifies that no data can be transmitted to main. Later, you will also uh, see that some of the data transfer can happen to the main. We pass some arguments to main. So between this, you can see some args, argc and argv and things like that. These are command line arguments. We will see that in future. Okay, so for now, main is a function like any other function which is started by the or which triggered by the OS, or the main function is the first function that's called in your program. Okay, so the other important part of your program is keywords. So in C, a keyword is a word with special significance, so you must not use keywords for any other purpose in your program. So for this reason, keywords are referred to as reserved words. So in this preceding example, int is a keyword, and void and return are also keywords. You can see below are the keywords that are available in C, like auto, double, int, struct, switch, long, break, else, case, enum, register. Okay, we will cover all of this because we have only these many uh, keywords to master in C, and with this you actually build your C programs. Well, the body of a function. The function body is the bit between the operating sorry, the bit between the opening brace and the closing brace that follows the line where the function name appears. So it's like name of the function, name of the function, and anything that follows between this opening brace and the close brace. That is what the body of your function. So in general, the structure of main is illustrated below. Okay, so one more point to notice, the function body contains all the statements that define what the function does. So anything that needs to be done within this function has to appear within this block. So anything between this open braces and close brace is also called a block. Okay, so let's come to a structure of the function main. So far we have covered. So the function header, so int main void is a function header. So this indicates the beginning of the function, and it is a definition and specifies the function name among other things. This just specifies function name, and it says what it should return and what are the arguments that it takes. Then you have opening brace, defines the start of the function body. The function body includes all the statements that define what the function is to do when it executes. So during execution of the function, everything that is there in between this brace and the closing brace will be considered the body of your function, and the statements within this will be executed. The closing brace defines the end of the function body. So this is what is the end of the function body. So here in the main, we have a simple body which consists of open brace, the printf statement, and the return statement. This printf statement actually prints, as you saw before in the beginning of this video, prints this program is meant to dissect. So that is what it prints to the console. So every function must have a body, although the body can be empty and just consist of opening and closing braces without any statement between them. In this case, the function will do nothing. So you will actually encounter in some programs, we just have a function body, empty body, so that it's some of this is basically useful when you want to uh, stub a code. So we will cover all the code stub, these concepts in the future. Then one more important part is outputting information. The body of the main function in the example illustrate includes a statement that calls the printf function. So if you see the printf here, this is a standard library function and it outputs information to the command line. It's actually the standard output stream, which is the command line by default. So in some of the embedded systems, you can see that you are or a serial communication. Your serial terminal becomes a standard output stream. So it may not come to the display as we saw here, but it will come to a terminal. It, I would say a serial terminal. So it all depends on how the printf function is implemented in the respective library function. Well, and the function arguments, the items enclosed between the parentheses following a function name. So as with the printf, the function in previous statement are called arguments, and they specify the data that are to be passed to the function. When there is more than one argument to a function, they must be separated by commas. So you have this printf statement here, and between the parentheses, you see this program is meant to dissect. This is what is the input argument to this. You can have something like more than one argument passed. So let's say if you have add, is a function, and you can pass two integers, int a and int b, and you can just return a plus b. So of course here it is integer. So such things we will do it in future, but one thing you need to understand is the function can have multiple arguments, so it can accept multiple arguments. So that is the understanding, that is the key takeaway. So here it prints this program is meant to dissect, and this is the argument to print a function. So this is the understanding with this simple C program. So we will cover more such things in the future. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.